from Valheria, Castiblanco, and who is a forage breeder with an industry background based in Cali, Colombia. She's with the Alliance of Bioversity International in SEAT and coordinating the program for grasses improvement, a program with more than 30 years of history. And she told us earlier she only has 122 slides, so this should go quickly. So over to you, Valheria. Thank you.
Thank you, Michael. Good morning, afternoon, and evening from Cali in Colombia. Some time ago, I was searching for a job, and I saw a job advertisement offering a position as forage breeder. I called my father to ask for advice, and he actually did not say much for the job. He just said, yeah, it would be wonderful to have you back home and all that. But he mentioned something quite shocking. He said, did you know that your cousins went to school thanks to those forages? During my time in SEAT, I have seen several of these cases. For example, Patricia, who you see in the photo, she, as well as my aunt, is able to send her children to school thanks to the implementation of improved forages. So I want to talk to you today about how can you convert the genetic diversity stored in gene banks into real opportunities for improved livelihood for farmers. You are probably already familiar with some of these facts, like the estimated number of livestock worldwide is a number near 17 billion. In fact, the question we address is how to feed this amount of animals in the most efficient way. Currently, we know about 2/3 of the world's total agricultural area is used to feed livestock. And this activity has been implicated in negative environmental impacts in various ways. Because of soil degradation due to unsustainable and like deforestation and overgrazing activities, and the emission of greenhouse gases. Now, forage production plays a major role for reduction of environmental impacts. First, by increasing productivity, which enables to reduce the amount of land designated to feed. And second, by increasing feed quality, which in turn reduces the greenhouse gas emissions. Unfortunately, it is not possible to have one unique superfeed, given that livestock production is highly diverse. And it's diverse in terms of the livestock systems, for example, grazing, mixed, industrial with a wide scale of grazing between. It's diverse in terms of animal species, cultural practices, agroecosystems. It moves from arid to humid, from the sea level to up in the mountains, at different latitudes, for example, and therefore, a diverse portfolio of highly productive forages is requested. And that has been the concern for the cluster 2. The development of forage alternatives and tools to increase productivity and reduce greenhouse gas emissions. Our work can be split in 3 parts. First, in close communication with gene banks, understanding the diversity, identifying the best germplasm, and make it directly available for end users. This has been done for hundreds of cultivars, but for the purpose of this exercise, we will talk about nappy grass. Second, exploiting the diversity by crossing the most promising accessions in order to breed even better varieties. Examples of that are the breeding programs of barley and tropical grasses. And third, the work with crop breeders to generate varieties that could serve the dual purpose, food and feed. Then the portfolio consists on nappy grass, selected accessions which are focused on the tropical markets for the niche cotton carrot, highly productive, alternative already tested in Ethiopia and Kenya, and ready to be scalable to other markets. To continue in the line of the tropicals, let me mention the interspecific hybrids of Urochloa. These hybrids provide tolerance to acid and poor soils, as well as spittle bug resistance. We continue on improving them for drought tolerance and pest resistance. The hybrids of Humidicola as well as the previous Urocloas, provide tolerance to acid and poor soils, but additionally, tolerate long periods under flooding conditions. However, we are in the process of improving their quality, and the hybrids of Megatherius maximus, directed also to the tropical market, the niche cut and carry, highly productive and exquisite quality, but in contrast with the Urocloas, more demanding in terms of soil fertility, almost reaching the demands of food crops. In the subtropical segment, we count on dual-purpose barley, which provides high grain and a straw yield combined with drought tolerance and is under continuous improvement of the straw quality. And last but not least, dual-purpose maize, which provides high grain and straw yield and quality, and is continuously improved for drought and temperature tolerance. All these products have already been tested in specific conditions, where they have been proven for improvements into the agro-silvopastoral systems, as indicated in the map, but for some, the dissemination across regions has already started successfully. Now, we would like to guide you through the story of one of these sub-product lines. For that purpose, we chose the example of the interspecific hybrids of Urocloa. This story starts back in the 60s, when the collection of germplasm was first done, and we started to understand their characteristics and usefulness. An amazing forage was identified. Fiat 606, with the name Basilisk, was widespread around farmer fields. Although most pastures in Latin America are located in poor soils, highly acid, it increased animal production directly and farms loved it, my aunt included. However, soon we discovered basilisk was susceptible to a pest, spiderwort. Then the request from farmers was, if we just had a basilisk, but with spiderwort resistance. And this claim became the main descriptor of our product profile. At that time, there wasn't any information on the basic biology of the species. We had no idea how to make crosses. Then the next steps were to identify sources of spiderwort resistance, which was found in the species Urocloa brisante, and develop all the tools required to build the product, how to measure the resistance efficiently, how to make the crosses, in fact, and discover the specific genetic markers associated with the traits of interest, produce protocols for drone-based image analysis, and with all that, create a breeding strategy that was finally implemented in stage 3, early in the 80s. There is where the breeder's magic occurs, the crosses and the first selections. And in 88, the first bunch of promising hybrids was delivered to partners, in this case to the NARS and private sector in Latin America. From the private sector, a family-owned Mexican company called Papalote. Due to the combined efforts of all these actors, the first interspecific hybrid of Urocloa worldwide reached the market in 2001. After that, new products have been released. Mulato 1, Cobra, Caiman, recently Camello, and the new generations are about to come. As it happened with the interspecific hybrids of Urocloa, all the products of our portfolio went through similar process. Cacamega 1 and 2, for example, which belong to the line of the napier grass, the HB 1964 and 1963 from the line of barley, and the hybrid maize CAH 153. For the product lines of Urocloa unicola and Megatherius maximus, you see they are still in between stage 3 and 4, and they will soon reach the mark. That's something that is about to come. But what does it mean for a farmer to have one of these products on their fields? In the words of Patricia, it means that her animals have more availability of feed over the year, even during the dry seasons, when other natural grasses are already dead. She sees the improvements in meat and milk production. You can follow her whole experience in the link below. We will share that afterwards in the chat. In general, we see that properly managed improved forages can double the amount of animals per unit area in comparison with natural grasses. And what is next? Our hybrids are reaching the market in East Africa, but we need to promote the dissemination to push it more, working in value chains and seed systems. This is the job of the cluster 4 within our flagship. Also, in Africa, we are starting to face a new pest called spider mites. As we successfully did for the speeder bug in Latin America, we aim to provide for Africa a hybrid with resistance to spider mites. Let me summarize here the main achievements of our portfolio. For the interspecific hybrids of Urucloa, we estimate that a total area of 1 million hectares has been reached, and over 20,000 smallholder farmers only in Africa have been using or have been in contact with Urucloa materials in general. However, this is only one out of all the products of our portfolio. In the tropics, we count on 1.5 million smallholder farmers who have already planted nappy grass selected varieties and we are now delivering 26 hybrids of Univicola this year to the farmers. In the subtropical segment, we are delivering 21 new varieties of barley to the partners this year, and last but not least, the dual purpose maize has reached more than 20,000 acres only in India. So I would like to acknowledge all the work of partners that has been done and made it possible to reach this point and obtain all these outcomes. And with that, I want to thank you for your attention, and I will give you back the word, Michael. Thank you very much.